Good afternoon, all of you. So today we are in the week two. So in this session, we will solve the problems based on the gate level and on chlorination topic. So let's begin with the first question. The first question, this question came in GATE 2011. The question says the chlorine was added to a drinking water sample. If the free chlorine residual and pH was measured to be 2 milligram per liter as Cl2 and 7.5 respectively, what is the concentration of residual OCl minus ions in the water? Assume that the chlorine gas was added to the water was completely converted to the OCl minus and HOCl. The atomic weight of Cl was 35.5. So, okay, so this was the question, and they have given one equation where OCl minus plus H plus reacts and forms HOCl, and the dissociation constant value is 10 to over 7.5. So, in this type of questions, so our approach should be the whatever data they have mentioned, we will write it one by one. So first thing is they have given that the free residual chlorine and pH was measured to be 2 milligram per liter and Cl2. So basically free residual chlorine they have given as 2 milligram per liter as Cl2. Okay, and the value of pH in the question they have given as 7.5. So the pH is 7.5. Okay, so since the pH is 7.5, using this given data, we can write minus log of H plus base 10 is equals to 7.5. So from here we can calculate the hydrogen ion concentration. H plus is equals to 10 raised to power minus 7.5. So with the pH value, okay. So using this data we calculate the H plus ion concentration. Now the question in the question they are mentioning free residual chlorine. So whenever some free residual chlorine basically means the concentration of HOCl plus Cl minus OCl minus. So the combination of both we consider it as free residual chlorine. So HOCl and OCl is a free residual chlorine which is equals to 2 milligram per liter as Cl2. So we can write it as free residual chlorine which is equals to HOCl plus OCl minus is given in the question as 2 milligram per liter as Cl2. So now the if you look at the so I think many new people have joined. I will again start from the beginning. So the question says the chlorine was added to a drinking water sample. Okay, if the free chlorine residual and pH was measured to be 2 milligram per liter as Cl2 and 7.5 respectively, what is the concentration of residual OCl minus ions in the water? Okay, so they have given the question, they have given one equation, and in that they are mentioning assume that the chlorine gas is completely converted to OCl minus and HOCl. So and in this equation they are mentioning OCl minus plus H plus is equals to equilibrium in HOCl, where dissociation constant is 10 raised to the power 7.5. So we started this question by writing the given data. First is free residual chlorine, second is pH value. Using the pH value, as we know pH is equals to minus log 10 H plus is equals to 7.5. The formula of pH is minus log 10 H plus ion. So that way we calculated the H plus ion concentration, which came out to be 10 to the power minus 7.5. Now in the given question they are talking about free residual chlorine. Free residual chlorine basically means HOCl plus OCl minus, which is equal to 2 milligram per liter Cl2. If you look at the answers, they are representing in terms of moles per liter. So it is in moles per liter. So therefore, we will calculate this in terms of moles per liter. So to calculate this moles per liter, since 2 milligram is Cl2, we have to divide it by molecular weight of Cl2. So 2 10 raised to the power minus 3 for gram, since it is milligram gram, and Cl2 weight is 35.5. So it multiplied by 2. So basically here we write molecular weight of Cl2. Okay, so this is in moles per liter. Now, molecular weight of Cl2 is 35.5 into 2. So 10 raised to the minus 3 into 35.5 into 2. So 35.5 into 2. So 10 raised to the minus 3, if you calculate it, you will get 10 raised to the minus 3 by 71. Okay. So this is the free residual chlorine, that is in terms of moles per liter. Moles per liter. And free residual chlorine I just mentioned, it is a summation of HCl plus OCl minus. HCl plus OCl minus. So remember this term. Okay. Now in the question they are given one equation. So we consider it as A. Now in the question they have given one equation where they have mentioned the dissociation constant value is 10 raised to the power 7.5. So if we have to write this equation in terms of K, we will write K is equals to HOCl product, then multiplication of reactant H plus and OCl minus. Okay. So now from here, and the value of the K they have mentioned it as 10 raised to the power 7.5. 10 raised to the power 7.5, and from here you can, so we can write it is like that, HOCl plus H plus OCl minus. Okay. So now if we look at the equation A, so from here if we substitute the HOCl value in the top, so it will, we will write in this way. So K is equals to HOCl by H plus OCl minus, which is equal as to, if we substitute the value of HOCl, so we have to write 2 into 10 to the minus 3 by 71 minus OCl minus divided by H plus and OCl minus. I hope till here it is clear. So now we know the value of K. In question it is given as 10 to the power 7.5. Here basically we substituted the value of in equation A. Using the equation A, we substitute the value of HOCl. Now 10 to the power 5 is equal to, which is the value of K, is equals to 2 into 10 to the minus 7 minus 3 by 71 minus OCl minus. Same we have to calculate this concentration. H plus. Now H plus concentration we calculated from the initial pH value, which is equal to 10 to the power minus 7.5. So we will place it here, 10 to the power minus 7.5, then multiplied by OCl minus. So if you multiply this, so 10 raised to the power 7.5, 10 raised to the minus 7.5 will comes out to be 10 raised to the power 0, which is equivalent to 1. So basically we can write it either OCl minus is equals to 2 into 10 raised to the minus 3 by 71 minus OCl minus. Now if we substitute LHS in RH, so in RHS if this OCl minus, if we shift it to the LHS, so it will come out to be 2 into OCl minus into 2 into minus 3 by 71. So from here we can calculate the value of OCl minus. It is 10 to the minus 3 by 71. If you calculate it, you will get the value as 1.408 into 10 to the minus 5 mole per liter. So in this, option A is correct. So anyone has any doubt till now? So I will again repeat this question. We started with question. So basically in this question they have given us two data, that is concentration of free residual chlorine and another is the value of pH. So free residual chlorine they have given in terms of as Cl2, that is 2 milligram per liter, whereas value of pH was 7.5. Now the next thing what they have given this equation, and in the question they have asked what is the concentration of residual OCl minus ion in the water. Assume that the chlorine gas was added to the water was completely converted to OCl minus and HOCl. So the our approach was we first use the given data like free residual chlorine and pH. Now using the given data, we calculate the H plus minus H plus ions value concentration, and then using the free residual chlorine we form the equation A, that is HOCl plus OCl minus is equal to 2 into 10 to the minus 3 by 71. Now, after using both these data, we focus on this given reaction. Using this value of dissociation constant K, we can write this equation as product of, so here we wrote HOCl, that is the product, and multiplication of the reactant H plus and OCl minus. Then using the above value, we converted HOCl minus in terms of OCl minus. So here it is, and then we use the data given for the dissociation constant, and using that data we calculated the OCl minus concentration, which came out to be 1.408 into 10 to the minus 5 moles per liter. Is it clear, or anyone has any doubts? Okay, so we will start the next question. In this question, the question says 16 mld of water is flowing through a 2.5 kilometer long pipe of diameter 45 centimeter. Okay, so the chlorine at the rate of 32 kg per day is applied at the entry of the pipe so that the disinfected water is obtained at the exit. There is a proposal to increase the flow through the pipe to 22 mld from 16 mld. Assume the dilution coefficient N is equals to 1. The minimum amount of chlorine to be applied to achieve the same degree of disinfection for the enhanced flow is. So basically in this question they are saying there is a one pipe. Okay. So in that the flow rate is initially 16 mld. Okay, and the rate of chlorine application is 32 kg per day. Cl2 32 just so in this the rate of Cl2 is 32 kg per day. Okay, and this is a disinfectant water from the other side. So and in this pipe the length is 2.5 kilometer and dia is 45 centimeter. So now they are asking, there is a proposal to increase the flow through this pipe to 22 mld. So there is a same pipe. So there is a proposal to increase. So this is 22 mld. Now they are telling what will be the Cl2 concentration. So now in this question they are asking what will be the Cl2 concentration if the flow rate is to increase to 22 mld. Okay. So now the one concept we should remember is for same degree of disinfection, for same degree of disinfection, T raised to power Cn is equals to constant, where T represents the time required to kill microorganism, time required to kill microorganisms, and the C stands for the concentration of disinfectant. Okay, where n, this is the n stands for the dilution coefficient. Dilution coefficient. Okay. So for same degree of disinfection, T c raised to power n is equals to constant. In our this question, the value of n they have given as 1. So here assume the dilution coefficient n is equals to 1. So basically that means T1 C1 is equals to T2 C2, where T1 is equals to L1 by V1. L1 means length of the pipe, V is velocity of flow, velocity. So n is equals to 1 here. Okay. So T1 is equals to L1 by V1. Now, if we substitute this to this one, so here we consider T1 equals to L1 by V1. So T1 we can write it as L1 V1 is equals to Q by A, Q1 by A, because Q is equals to AV. So from there we can write V is equals to Q by A. So we wrote the same thing. So we can write it as L1 A by Q1. Okay, so this is the time. So concentration Q1 is equals to W1 by Q1, where W1 is the weight of the disinfectant per day, weight of disinfectant per day, and Q1 is the discharge per day. So now, since we were telling T1 C1, so T1 value is equals to L1 A by Q1, where L1 is the length of the pipe, A is the area, Q1 is the discharge per day. C1 concentration is equals to weight of disinfectant per day, and Q1 is the discharge per day. So basically, when we are writing like this, T1 C1 is equals to T2 C2. So using this two, we can substitute the value of T1 is L1 by A into Q1 into C1 is W1 by Q1 equals to L2 by A by Q2 into W2 by Q2. So here the length of the pipe and the area is assumed to be constant because no such information is there regarding the length and regarding the diameter of the pipe. Only thing is that there is a proposal to increase the flow. So remaining thing is constant. So since remaining thing is constant, so basically L1A and L2A will be get cancelled because both are same. So we are left with W1 by Q1 square, W1 by Q1 square is equals to W2 by Q2 square. So if we write in terms of W2, it will be Q1 uh, Q2 by Q1 whole square into W1. Q2 is 22 mld, Q1 is 16 mld whole square, and it is 32 kg per day is applied. So the value of W2 came out to be 65.5 kg per day. So to achieve the same degree of disinfection, we have to add chlorine of 60.5 kg per day. So in this option A is correct. So is it clear? This question is clear. Anyone has any doubt till now?
No, sir.
Okay. So before beginning the next question, I will just summarize this again. So in this, there are two pipes. So first pipe they are telling that the chlorine dosage is 32 kg per day and the flow rate is 16 mld. And the dimension of the pipe they have mentioned as length is 2.5 kilometer and diameter is 45 centimeter. So they are telling if we have a flow rate of 16 mld and we are adding 32 kg per day, what will be the chlorine dosage if what's achieved to achieve the same degree of disinfection? So this is the main line to achieve the same degree of disinfection if our flow rate is increased to 22 mld. So here we have to find now the what will be the dosage of chlorine. So I mentioned for same degree of disinfection, product of time and concentration is equals to constant. T is the time required to kill microorganisms. C is the concentration of disinfectant. Since it is a constant, so we can write it as T1 C1 is equals to T2 C2. Now time. So basically there is nothing mentioned in the question regarding the time. So we can substitute it as L1 by V, but is length of pipe by velocity of flow. Similarly, we did for the concentration also. After substituting this in this T1 C1 and T2 C2, we derived one equation which is W2 is equals to Q2 by Q1 ka whole square into W1. We substituted the values given in the question of Q2, Q1 and W1, and from here we got the value of W2, that which came out to be 60.5 kg per day. So now the third question. So in the third question says an effluent at a flow rate of 2670 meter cube per day from sewage treatment plant is to be disinfected. The laboratory data of disinfection studies with a chlorine dosage of 15 milligram per liter yields a model which is N naught Nt is equals to N naught e raised to power minus 0.145 t, where Nt is equals to number of microorganisms surviving at time t, and N naught is the number of microorganisms present initially at time t is equals to 0. The volume of disinfection unit required to achieve a 98% kill of microorganisms is. So, in this question, we will first write the given data. So, basically, they have given the flow rate which is 2670 meter cube per day. Okay, chlorine dosage 15 milligram per liter, and they have given one equation Nt is equals to N naught e raised to power minus 0.145 t. Okay. Now the question says the what is the volume of disinfection unit required to achieve a 98% kill of microorganisms. So basically 98, if 98% microorganisms are killed, so that means only 2% are surviving. So since only 2% are surviving, so we can write this Nt is equals to N naught e raised to power minus 0.145 t as Nt by N naught is equal to 0.145 t. So since 2% are surviving, so we can write it as this fraction. This is the at time t, and this is the total number of microorganisms. So we can write it as 2% as 0.02, because to kill 98% of microorganisms, because they are asking volume of the disinfection required to achieve 98% kill of microorganisms. If 98% is the kill, 2% is the survival. So it is 0.145 t. So from here, if you calculate, you will get the value of t as 26.979 minute. Okay, so time came out to be 26.979 minute, and volume of the tank is we know the volume of the tank is. So basically from this we got discharge is equals to volume by time. We know that. So for calculating the volume, we can write it as discharge into time. So this is what I wrote it here. So discharge is 2670 meter cube per day. So this is meter cube per day. That is 2670 per day. So per day means 24 hour I have to convert per day into minute. So 24 hours and hour into minute 1 hour 60 minutes into time. So this is also in minute, this is also in minute. So minute will get cancelled and only meter cube will come out as final unit. So if you solve this, you will get a 51.71 meter cube. So I hope this question is clear. So I will just re-summarize it. So in this question, they are asking, they have given one model equation, nt is equals to n naught, and they are telling nt is the number of microorganisms surviving at time t, where n naught is the number of microorganisms present initially at time t is equals to 0. So, and they are mentioning an effluent at a flow rate of this much from a sewage treatment plant is to be disinfected. The laboratory data of disinfection study with the chlorine dosage of 15 mg per liter yield this model. Okay, so now they are asking the volume of disinfection unit required to achieve 98% kill of microorganisms. We simply use this given equation because NT here is the number of microorganisms surviving at time t. So at time t only 2% are surviving out of the total n dot microorganisms. So NT by N naught is equals to e raised to power minus 0.145t. Since 2% are surviving, we wrote 0.02 is equal to e raised to power minus 0.145t. So the time came out to be 26.979 minutes. And using this, we calculated the volume of the tank, which is Q into TD, detention time. So 2670 divided by the 24 into 16 to convert per day into minute and multiplied by this time. So we got 51.71 metric cube. So this is the answer. Anyone has any doubt in this?
No, sir.
Okay. So now this is the last question. After that, we will discuss few concepts related to chlorination. So the question says if 90% of flea Cl2 is to be in the form of HOCl, find the pH of the water required. So in this question, they are asking regarding the pH of the water. So chlorine. So remember chlorine reacts with water to produce hypochlorous hypochlorous acid. Uh, produce hypochlorous acid which dissociates to give hypochlorite ions and protons. Thus, we can write it as HOCl minus giving H plus OCl minus. So now, whenever also other thing is at 20 degrees Celsius, the dissociation constant K is equals to 10 ratio 2.5 into 10 ratio minus 8. So remember this 2.5 to 10 ratio minus 8, which basically we can write it as H plus OCl minus divided by HOCl. So now they are asking 90% of flea chlorine. So in the question they are asking 90% of flea chlorine is in the form of HOCl. So I I told you just now, free chlorine basically is a summation of HOCl minus plus OCl minus. This thing we termed it as free chlorine. Okay. So now if 90% of free Cl2 is in the form of HOCl, so we can write it like that: HOCl by HOCl plus OCl minus is equals to 90%, which is 0.9. So from here we can calculate OCl minus if you do, and HOCl. So we can write it like that: 1 upon 0.9 minus 1. So this thing only we wrote like this. So divide numerator and denominator by HOCl. So you can get in this form: 1 upon 0.9 minus 1. So this is our equation A. Okay. So just now I told that in this reaction, so HOCl, where it is dissociating into H plus plus OCl minus, if we write in terms of K, it is equal to 2.5 to 10 to minus 8 is equal to H plus OCl minus divided by HOCl. So from there, so this we have to substitute in this equation, this one. So if we substitute this one, we can write 2.5 into 10 to minus 8 is equals to H plus 1 upon 0.9 minus 1. Can we write it like this? If we substitute this equation A in this equation, so basically we are substituting this much. So H plus multiplied by the value of this one. So this we can write. From here, if we solve, we get the value of H plus as 22.5 into 10 to minus 8. So pH value you can calculate as 10 to minus log 10 H plus. So 22.5 into 10 to minus 8. So the value will come out to be 6.647. So the pH will be 6.647. So is this question is clear?
Repeat this question, sir.
What? Should I repeat?
Yes, sir.
Okay. Yeah. So this question asks if 90 to 90% of free Cl2 is to be in the form of HOCl, find the pH of the water required. Okay, so basically whenever question comes in this form, always remember this equation: HOCl dissociates into H plus and OCl minus, and at 20 degrees Celsius the K value, dissociation constant, is 2.5 to 10 to minus 8, which is equals to product multiplication of the product and reactant divided by the reactant. So first this is the uh, knowing, we know this much we know. Now the based on the question, they are mentioning if 90% of free Cl2 is to be in the form of HOCl. So I mentioned free Cl2 basically means it is the sum of the concentration of HOCl minus plus OCl minus ion. So if 90% means if it is in the form of HOCl, so basically in fraction we can write HOCl divided by free chlorine, total chlorine, is equal to 0.9. So from here, if this equation you write it in this form, OCl minus and HOCl, just normal mathematical equation only, we have to solve this, and it came in value of this 1 upon 0.9 minus 1. So we got this now. Okay, using the given data in the question. Up till here we got whatever we got it from the given data. Now we have substituted this OCl ratio of this in the this thing which we knew earlier based on the concept. So after substituting the ratio of OCl minus HCl minus in this equation, we can write it like this: 2.5 to 10 to the minus 8, where H plus multiplied by 1 upon 0.9 minus 1. From here, we calculated the value of H plus. Here we calculate the value of H plus. Using this H plus, we calculate the value of pH. Is it clear? Basically, this equation we substituted in K is equals to H plus OCl minus and HOCl. So basically, if this equation if we substitute it here, we will get this thing. Is it clear now?
Yes, sir.
Okay. So I hope it's clear. For if anyone has any doubt, you can ask. So few other things also I would like to mention here. So chlorination. So these are some concepts which you should remember in chlorination. Okay. So in chlorination, basically, whenever we add Cl2, it forms HOCl, hypochlorous acid, hypochlorous acid plus HCl. So remember, this usually happens when pH is greater than 5. Okay. So now this HOCl will also get dissociated in H plus plus OCl minus. Okay. The dissociation of H plus. So basically HOCl is unstable, hence breakdown at higher pH. Breakdown at higher pH. So now when HOCl is dissociated into H plus, it usually happens at pH greater than 8, and the HOCl remains HOCl at pH less than 7. So basically in this what happens, OCl minus is comparatively weaker disinfectant compared to OCl minus. This is because OCl minus is negatively charged, therefore it repels the bacteria, because bacteria are also negatively charged. So there is a repulsion. So that's why we try to make pH just lesser than 7. So if we have to write, so entire thing now I will write. So at pH, so following conclusions are: at pH less than 5, chlorine does not react with water. Okay, and remain as prechlorine. So equation 1 you can see, at pH less than 5 Cl2 won't react. So pH should be greater than 5 for the Cl2 to get dissociated. Now second thing is HOCl plus Cl minus and Cl2 are combined called free available chlorine. Okay. Out of these forms of free available chlorine, second thing is third thing basically. Out of these forms, HOCl is the most destructive one. Most destructive. HOCl is 80% more effective. 80% more effective than OCl minus ion. Hence, pH of the water should be maintained. Hence, pH of the water should be maintained slight slightly below 7. Hmm. Okay, so this thing you remember, this is the chlorination. Also, other things are forms in which chlorines are added. Forms in which chlorines are added. First is as free chlorine, liquid or gaseous form, liquid or gaseous form. Second is hypochlorite. Hmm. That is hypochlorite, bleaching powder. Third is chloroamines, ammonia and chlorine. And fourth is chlorine dioxide. Chlorine dioxide, ClO2. So these are the major methods. Okay, and other thing is, uh, so this I talked about chlorination. So and a few other thing is you should also know that when chlorine, um, so these are the things. So other thing is, if ammonia is present, if ammonia is present in water, chlorine immediately reacts. Chlorine immediately reacts and forms chloroamine. The benefits of chloroamine is, first thing, they are stable, and the second thing is remain more time in water. Okay, so if NH3 plus HOCl forms NH2Cl plus H2O. So this is known as monochloroamine. Okay, so now if it is NH2Cl plus HOCl, it is dichloramine. If it is NHCl plus HOCl, it is NCl3 plus H2O. So this is all about. And other thing is, few other things which I wanted to mention. These are the major methods. Okay, chlorination. So these are the major methods, and minor methods includes. So if we talk about some minor method of disinfection, So minor method is first is treatment with lime. So treatment with lime, basically excess lime kills bacteria. So in this, basically excess lime kills bacteria, but excess lime has to be removed before supply of water. Okay, and for this, before supply of water, for this recarbonation is done. Recarbonation is done. Recarbonation is basically when CO when CO2 is passed, it forms precipitate as CaCO3. So basically, so excess lime is removed from the water. So this is treatment with lime. Other is with treatment with nascent oxygen. Treatment with treatment with ozone. Treatment with ozone. So basically, ozone will split into O2 and O, which we call it. This O is termed as nascent oxygen. So nascent oxygen is a powerful oxidizing agent and it removes organic matter as well as bacteria from the water. So so remember this nascent oxidizing agent is a powerful oxidizing agent. Powerful oxidizing agent, and it removes organic matter as well as bacteria from the water. So also ozone removes color, taste, odor also. Hmm. So this is treatment with ozone completed. So O3 produces O2 plus O, which is nascent oxygen. It is a powerful oxidizing agent. But the major problem is with this, it does not ensure safety. It does not ensure safety against future contamination. Okay, so it because does not also it does not form trihalomethane and haloacetic acid, which is carcinogenic. So this is treatment with ozone is one thing. So treatment with lime, these are two till now we discussed, and other thing is treatment with KMNO4. Treatment with KMNO4. Okay, so this will be small n. So this is the third one. See, so treatment with KMNO4. Remember, basically, this is commonly applied in villages which are contaminated with a less amount of bacteria. So in a well, these are generally added in the well. So whenever you will add this, a pink color should appear. A pink color should appear. So if pink color is not appearing, that means you have to add extra uh, KMNO4 till the pink color stands. So also the well in which it is added, it should not be used for the next 48 hours. So basically, so if in words you have to write, so KMNO4 is mixed with water in a bucket and added to well. After mixing in the bucket. Hmm. So if pink color forms because of this. If pink color disappears, that means that organic matter is present. Hence, more KMNO4 is added until the pink color stands. Also, the well, as I mentioned, it should not be used for the next 48 hours. So it removes around 98% of bacteria and uh, it removes 90% of bacteria, and also dose is normally 1 to 2 milligram per liter. So this is the dosage amount, 1 to 2 milligram per liter, and it is 98% of killing bacteria. So another thing which I want to mention is that people often get confused between the chlorination and the sterilization. Sterilization and disinfection. So in next slide only we will discuss this properly. So disinfection and sterilization. So always remember, disinfection is maybe defined as the process of destruction. So I will write it properly in words so that it will be helpful for you. So disinfection is defined as the process of destruction or inactivation of harmful microorganisms. Microorganisms in water, either by physical process, either by physical process or chemical process. Okay. So if we talk of physical process includes heating, heating, ultraviolet radiation, and chemical process includes the usage of chemicals. Okay. So and chemical which are Cl2, Br, iodine, ozone, KMNO4, which we discussed just now previously. Okay, some alkalis and acids also in chemical process. So dis- in whereas in sterilization, all my organisms are usually killed by a physical phenomena such as boiling for a long period, such as boiling for a long period, whereas in disinfection, just a second, whereas in disinfection, just give me just 2 minutes. So whereas in disinfection, disease or illness, disease or illness causing microorganisms are reduced to such a low level that no infection or disease result when water is used for domestic purpose. Okay. So basically, the major differences in sterilization, all organisms are usually killed by physical process such as boiling for a long period, whereas in disinfection, only disease or illness causing microorganisms reduced to such a low level that no infection or disease results when water is used for the domestic purpose. So disinfection is basically a essential minimum treatment requirement for any drinking water, and it is the final chain in the treatment process. Okay. So this is for all our today's class. If anyone has anything to ask, you can ask. So thank you everyone. So please leave. So today is the end of the session, and yeah, welcome. So next again we will meet on next Saturday. I will upload all these videos in the YouTube. You can again go back and refer these videos. Thank you.